And by the way, Chrome. Usually, I upload all my recordings in third-party applications, YouTube. Basically, you can look for my name. And you see this channel. I usually upload my recordings, the class recordings here, and you'll see some playlist I already made since last year. And if you don't understand my class in English, you can actually listen to the class which I recorded in Bahasa. This is the class for for computer science, and you will see these recordings. So, so if you don't understand my English, then you can still try to understand it in Bahasa, basically. Okay. But I hope that all of the things that I deliver will be easily understood by you. Well, my experience with chemical engineering students in Universitas Pertamina, uh, I think you are one of the best students in Indonesia, so I hope that you can understand my explanation easily. And let's start the materials for this first session. So this first session, we learn about inequalities and absolute values. By the way, if you have questions outside the class, you can reach me via email or Microsoft Teams. So you can just chat me via Microsoft Teams. So this chat, and you look for my name, or I mean, you can try to look for my name and then just chat me. So it's quite easy, and you can ask me anytime, but I will only answer it during working hours. Let's start this slide. Okay, we will learn about inequalities and absolute values. Recording started. Okay. What we will learn for this part, for this session, is first about solving inequalities, and then second about absolute values, and then in the last part you will see uh, some I call it take-home challenge, but it is actually in the syllabus is this part, latihan mandiri and latihan tantangan. But I already wrote all the questions here, so you don't really need to have the book. Okay, let's talk about solving inequalities. I believe that you already got techniques to solve inequalities from your high school, right? Anyone don't understand about inequalities? Can you raise your hand, please? No. So I think you already, all of you already know about inequalities and how to solve them. Basically, if we are faced with problems to solve inequalities, then solving inequalities is basically similar to solving equations. So if you have equations, for example, quadratic equations, linear equations, or cubic equations or quartic equations, usually you solve it by simplifying the equations or factorizing the equations, the polynomials, into some into its factored form, which usually have a degree of 1. And then from that, you can easily get the roots of the equations. But what about inequalities? With inequalities, basically the same. We can add the same numbers to both sides of an equality. For example, let me move to this OneNote. For example, if we have inequalities like, let's say, x greater or equal to a, it can be equal, it can be greater or equal, it can be just greater, it can be less than or equal, it can be less, can be anything, as long as it is inequalities. The first step, you can add the same number to both sides of the inequality. So in this case, you can try to, for example, add -3 maybe I need to make better. Okay, let's say this is x plus a greater or equal to 0. So what is the solution that satisfy this? What are the values of x that satisfy this inequality? And first step is we can try to add some values to both sides of inequalities. So in this case, we can add negative of a to the left side of the inequalities and also the right side of the inequalities. From here, we will get x greater or equal to negative of a. And here, in this case, this is the solution for above inequalities. That is the first option. The second option, the second operation that we may use is by multiplying both sides of an inequality by the same positive number. Why positive number? Let's say we have this problem. A of a times x equals greater or equal to 0 or no, to some values p. Then what are the values of x that satisfy this inequality? In order to get that, we can multiply both sides with positive value. Let's say we multiply them by 1 over a, assuming that, let's say, a is positive. So we multiply left side by 1 over a and right side by 1 over a. Then from here, we will get x greater or equal to p over a. In this case, since we multiply multiply both sides by positive values, in this case, the sign, this inequality sign, does not change direction. So the direction of the inequality sign remains the same. So the next operations that we may use is multiplying both sides of inequality by the same negative number, but then the direction of the inequality must be reversed. Let's say we have, again, a positive, and we have this wait. And anyway, let's say we have this, and then we have the inequality now negative of 1 over a x greater or equal to b. Then we can multiply both sides by negative of a, and okay, so the left side we multiply by negative of a, then that's then the right side we also multiply by negative of a. But since negative of a is negative, then this direction of the inequality, we need to reverse it. So now it becomes less than or equal to. So we have now x less than or equal to minus a b. Up to this point, any questions? Oh, still easy? Still trivial. Okay. It's still easy enough for you, I think. Then let's try to solve this quadratic inequality. So basically what we want to do is to make one of the side of the inequality to be equal to 0. How to do that? First, we add minus 6 to both sides. Since we just add minus 6 to both sides, we get this, and the direction of the inequality still remains the same. And then we factorize this quadratic function into its factor like this. So we factorize the left side and right side, and since the right side is 0, still 0, and the left side is now x minus 3 times x plus 2. After that, we put on this, we draw this line, solution line, and then we do some tests. I think it is better for me to. Okay. Now we have x squared minus x less than 6. So we add minus 6 to both sides. So we have x squared minus x minus 6 less than 6 minus 6, which is 0. So now we have x squared minus x minus 6 less than 0. And we factorize this part into x minus 3 times x plus 2, we have less than 0. From here, we have that the left-hand side of this inequality is equal to 0 if equal to 0 if x is equal to 3 or x is equal to minus 2. From here, we draw a solution line like this, and we put this annihilator, or what's a proper word for this? Basically, the value that makes this quadratic polynomial equal to 0. Then we put this here at minus 2 and 3. After we draw the solution line, we see that the sign does not involve equalities, so it's just strictly less than 6, or the quadratic polynomial x squared minus x minus 6 is strictly less than 0. Then we draw a circle, but what is inside the circle is blank. So looks like we are drawing a donut, a circle with nothing inside. This determines that this says that minus 2 and 3 are not included in the solution. And then after that, we draw some kind of wall like this. And now we take one number. Let's say we can easily take 0 because it is between minus 2 and 3. We have 0. And then we test to put 0 into this polynomial, to this quadratic function. When we put 0, 0 squared minus 0 minus 6, the value is positive or negative. Here, positive or negative?
Negative.
Negative. Since when we put 0, we have 0 squared minus 0 is 0, and then minus 6. Then minus 6 is negative. In this case, we can just put this sign negative here, and then the other side of the walls, we will change the sign. So we know that if we have this negative here between minus 2 and 3, then we know that in this side is positive, and on that side, on the right side, is also positive. The question is, which area is the solution of the inequalities? We see that the inequality sign is less than, strictly less than. So we have to find less than 0, meaning that we need to find the intervals for which the value of this quadratic function is negative. So it happened to be this part. So we have this part, since the value of this area is negative, then the solution of the inequality above is this part. Understood?
Yes, sir.
Yes, sir.
How
Yes.
to write the solution? How to write the solution? In this case, since minus 2 and 3 are not included, then we have x -2, 3, and x is in between -2, 3. And the sign are strict equality. To write the solution properly, first option, you can write the solution like this, as what I showed you before. The second option is that you can also write the solution in this way. How to read this second term, the second way of writing the solution. Anyone of you know of this notation?
Sir, sigma, sir, or no?
No.
Element, sir.
Yep, that's the answer. Yeah. This E that looks like the letter E means element. So how to read this is X is element of the interval here. And how to read this interval? This interval means that the value of X is in -2, between -2 and 3. And if you see that here I use the normal bracket. Normal bracket means that the number on that side is not included. So open normal bracket -2, meaning that -2 is not included in this interval, and open the normal closed bracket, meaning that here 3 is not included in this interval. Okay, any questions up to this point?
Not yet, sir.
Okay, now the next example is we try to solve this inequality. X minus 1 over x plus 2 greater or equal to 0. So here we see that the inequality, both the numerator and the denominator, are already in their factorized form. So we know that the value of the numerator will become 0 if x is equal to 1. See 1 here. And the value of the denominator is equal to 0 if x is equal to -2 here. And then after that, we draw the solution line. And then we put again the circle. But now notice that the circle in -2 is blank circle, is an unfilled circle, even though this inequality contains equal part. So we have greater or equal to, meaning that the circle must be filled like this. But since the denominator cannot be 0, then -2 cannot be part of the solution of this inequality. That's why we need to draw a blank circle here. And then after that, we simply test the value like before. We put 0 and then the value of this, the left-hand side of the inequality is negative, because if we put x equal to 0, we have -half. Then in between -2 and 1 is negative, and the other sides are positive. And since the inequality is greater or equal to 0, then we have the solution is the left side part and the right side part. How to write the solution? We have here x less than, strictly less than -2, or x greater or equal to 1. So any value of x that is strictly less than -2 and greater or equal to 1 can satisfy this inequality, basically. The other way to write the solution of this inequality is by using set notation like this. X element of this set. The first set is minus infinity up to -2. But since -2 is not included, then we use the normal bracket. And for infinity, either negative infinity or positive infinity, we cannot use square bracket because we can never reach infinity, actually. That's why the open bracket is still normal bracket. And since -2 is not included, then we use the normal bracket to close this interval. And this is the first part, which means x strictly less than -2. And then the second part is x greater or equal to 1. And you notice that the open bracket here, I use square bracket, meaning that 1 is included in the solution. The 1 is also in the set. That's why we need to use the square bracket. And we use the set union. You see that this is the symbol for OR. Since we use OR, we use union. Because we don't need the intersection, but we need the union of the two sets. Any questions for this example, or is it still easy for you?
Sir, can I ask a question with bahasa?
Yes.
Itu kan yang -2-nya kenapa bisa nggak termasuk, Sir?
Okay. -2 cannot be part of the solution because of this red note that I write. The denominator, or in bahasa penyebut, cannot be 0. Why? Because if the denominator is equal to 0, then we will have an undefined, we will have the expression that cannot be defined. So in bahasa, pembagian ini, kalau penyebutnya 0, maka pembagian ini tidak terdefinisi. We don't have any value for this quotient. Understood?
Yes, Sir. Thank you.
Okay, so when you solve inequality, whenever you find this kind of function or this kind of form, quotient form, which contains numerator and denominator, as long as you find, and when you find any value of x that make the denominator 0, then that value cannot be part of the solution, even though the inequality sign contains equality, contains equal part. Understood? So I already put this note so that you can remember it. That's why I try to write it in different color. Okay, next example. This is quite tricky. For this example, we have this inequality. Insert space. We have the inequality. Okay. x plus 1, x minus 1 squared multiplied by x minus 3 less than or equal to 0. You see that this inequality, I mean, the left-hand side of this inequality is already in its factorized form. So we have that this part is equal to 0 if x equal to -1 or x equals to 1 or x equals to 3. The next step is we draw the solution line. We have -1, 1, and 3. Now, since the inequality sign contains equal part, then what kind of circle that we need to draw here? The filled one or blank one?
Filled.
Filled circle, right? Because this contains this equal part. So we have to draw the filled circle first, and then the next step is we draw some kind of wall separating the solution line, and then we check a value. Here, let's say 0 is the easiest part. If we put 0, the value of this multiplication is positive or negative. 0 plus 1, 1, 0 minus 1, but squared, then plus 1. So we have 1 times plus 1 is plus 1. And then 0 minus 3, negative 3. So we have 1 times negative 3, we have negative. So this side is negative. Okay. Now, aside from building this wall, we also need to take we need to pay attention to the power of each factor. So we have this power actually x plus 1, the power is 1. That's why in this part where x equal to -1, we need to also take note that this is 1. And then x equal to 1, the power is 2. That's why we also need to put 2. And then in this case, 3, the power x minus 3 power is 1. You write 1. Why we need to write this? This determines the change of sign. So we have in this case, in the 0 part is negative. And since the wall on -1, we write 1. 1 is an odd number. That's why it changed sign to positive. But when we want to try to cross the wall at x equal to 1, the power is 2. 2 is an even number. The sign does not change. So in this case, the sign remains negative. And then after that, over the wall, we write an odd number. So we change the sign again to positive. So it is actually the trick. And since we want less than or equal to 0, that's why the solution base, the solution set should be this part, the negative part. So in this case, the solution is -1 less than or equal to x less than or equal to 3. Or we can also write it by x in square bracket, open square bracket, minus 1, comma 3, close by square bracket. Any questions up to this point?
Sir?
Yeah.
Can I ask in bahasa?
Yeah, you don't need to ask my permission. You can just ask in bahasa.
Oke. Tadi yang antara 1 sama 3 itu tadi kenapa min ya, Sir?
Okay. Why the sign does not change, you mean?
Yes.
Okay. Why the sign does not change is because the power is even, an even number. So basically, we can also see it like this. We draw the solution line, minus 1, 1, 3. And then we draw the circle, filled circle, because it contains equality. And then we draw the wall, because the power of x plus 1, which means that x plus 1 equal to 0 if x equal to minus 1, and the power is 1, we build just one wall. And x minus 1, the power 2, it is 0 if x is equal to 1. That's why in here we draw 2 walls like this. And then x equal to 3. At this point, x minus 3 power 1, we draw just one wall. And if we put 0 here and we test the value of 0, we get the value negative. So basically we change the signs like this. Plus here negative, plus negative, positive, like this. But this part, even though it is okay, let me change the color to green. Even though there is a positive sign here, but it only on this point 1. We don't need to care about this. So the trick is actually like that. So we have in this side negative, and in this side between 1 to 3 also negative. That's basically why the sign does not change, it still remains negative. And also instead of building this kind of wall, it is better to just put the number of the power here above the wall. And if we know that the power is positive, if the power is even, then the sign does not change. If the power is odd, then the sign changes. For example, if we change this inequality to x minus 3 power 3, and x plus 1 power 5. So we write here the power is 5 and here is 3. It is easier to put it like this. Then since we have 5 is an odd number, the sign change. 3 is an odd number, the sign change over the wall. Instead of, it is better to write it like this instead of, you see, building like this, 3 walls like this. We have minus, plus, minus, plus, the same. Anyway, before 3, the sign minus, after 3, the sign plus. Or we can also try this trick with power 5, then we have to make like 5 walls like this. So we have here plus, minus, plus, minus, plus. You can also try to use this trick, but I think this trick works better. The upper one. Okay, understood?
Yes, sir. Thank you.
Quite easy, right?
Yes.
It's okay. Maybe I understand that you guys are actually, I mean, you had like 3 or 4 months long of holiday, right? Before this class. So yeah. Oh, something wrong. Anyway, it's like that. So now we have this solution. Okay. Classroom exercise. You can try to solve this inequality. Can you tell me what is the solution for this inequality? Not responding. What is the solution for this inequality?
Lima per 2 bukan, Pak?
Okay, x less than minus or, oh yeah, x less than or greater than. I think x greater than minus 5/2, right?
Yes.
No. Wait a moment, itu OneNote and task. Luckily, still there. So seven x minus 2 less than or equal to 9x plus 3. Then we have from here we have 2x greater or equal to minus 5. So we have x greater or equal to minus 5/2. So this exercise is still simple. Now let's try the next exercise. What is the solution for this exercise? Anyone know? Minus 3 less than 1 minus 6x less than or equal to 4. So in this case, what we do is to minus 3. This part is 4. So first, what we can do is to add or subtract a value for all sides. Let's say to remove 1, we add minus 1 to mid part of this inequality. figure. So we add -1 so that we can remove 1 to the middle side, to the middle part. And then since we add -1 to middle part, so we have to also add -1 to the left side and the right side. From here, we have -4 less than -6 x less than or equal to 3. -4. Now we can multiply by -6, -1/6. So we multiply it by -1/6. We also multiply here by -1/6. And also on the right side, multiply by -1/6. In this case, since we multiply all sides by negative number, the sign change direction. So here it changed to greater to, and then on the right sign we have greater or equal to. Meaning that from here we will have 4/6 greater than x greater or equal to -12 or -3/6, or we can also write it like this: x in between -12 and 2/3. Any question for this exercise? Understood?
Ngerti, Mister.
Understood, sir.
Try to solve this inequality. 2x² + 5x - 3. Let me write it in this 2x² plus 5x - 3. 5x - 3 greater than 0. Try to solve it. I'll give you 1 minute. So anyone have the answer already? What is the solution for this inequality?
Setengah sama -3, bukan?
So what is the factor of this quadratic form?
2x min 1, x plus 3.
2x minus 1, x plus 3. Let me test it, okay? 2x squared, 2x times 3, 6, minus 1x, plus 5x, minus 3, okay. So here, equals to 0 if x is equal to 12 or x is equal to minus 3. Now we draw the line minus 3 and half. We draw the circle, length circle, since it is a strict inequality, and we put 0 since in 0 the value is negative and here is positive. So which part is the solution? The middle, left, or right? Which part of this solution line is the solution to this inequality? The middle part?
No, sir. The
Then this part, right? So the solution to this inequality is x less than minus 3 or x greater than half. So the answer is exercise. What is the solution to this inequality? X plus 4 over x minus 3 less than or equal to 0. So for this exercise, is equal to 0 if x equal to x equal to 3, and for the numerator part is equal to 0 if x is equal to minus 4. Then we draw the solution line again, minus 4, 3. Since the denominator cannot be 0, then we have blank circle here. And for the numerator, we have a filled circle like this. And since if we put 0, the value is negative, and the other side is positive, then we have the solution to be this part. So the solution is minus 4 less than or equal to x less than 3. Any questions up to this point? Any question? No? Okay. Now we go to the next part of this slide. Now we are talking about absolute value. We still have about 30 minutes left, half an hour left. So in this half an hour, we will talk about absolute values. What is absolute value? Basically, by definition, the absolute value of a real number x, or we can denote it by x is bracketed by this straight lines. This is the notation for absolute value, and it is defined by x if x is non-negative, and minus x if x is negative. Basically, if we have the absolute value of 3, then what is the absolute value of 3? Since 3 is already greater than 0, then the absolute value of 3 is 3. What about the absolute value of minus 3? Minus 3. Then since this is negative, then the absolute value of minus 3 is negative of minus 3. That is 3. That is how absolute values work. And it has some properties that you need to know. The first property is that absolute value of multiplication of two values are the multiplication of their respective absolute values. So absolute values of A times B is absolute values of A times absolute value of B. For the division, it's the same. Absolute value of A over B is absolute value of A over absolute value of B. These first two are quite easy to understand because I think you already got it in high school. The next two properties maybe you may have not heard it before. The third property is called triangle inequality. Why triangle inequality? Because this property is actually can be visualized by a triangle. So triangle inequality says that absolute values of A plus B is always less than or equal to absolute value of A plus absolute value of B. Why? Let me draw a triangle. Let's say we have this triangle. And then let's say this is a vector. And we want to know the length of the vector. This is vector A, vector B. Then the length is usually denoted by absolute value. The absolute of A, absolute of B, and the length of this. In vector notation, this is A plus B, and the length is length of A plus B. And here we know that the length of A plus B is always less than or equal to length of A plus length of B. But you don't really need to know this for now. As long as you know that there is this triangle inequality and you know how to use it, that's fine. That's enough. And the next properties is that absolute value of A minus B is always greater or equal to absolute value A minus absolute value B. Example. Oh, before the example, how to solve inequalities that involve absolute values. Suppose that we have any real number A and A is positive. Then if we have absolute value of X less than or equal to A, it means that it means that X is always in between minus A and A. And if we have absolute values of X greater or equal to A, it means that X is less than or equal to minus A, or X is greater than or equal to A. For example, how to solve this inequality? Absolute value of X minus 4 is less than 2. We check this slide. The absolute value of X less than or equal to A. And we have the condition that A here is equal to 2, which is positive. And we have this absolute value, meaning that we can use this rule. Then whatever inside the absolute value is placed in between the value of negative A and A. So we have X minus 4 is in between minus 2 and 2. And then after that, we simply add plus 4 to all sides. So we get X is between 2 and 6. Up to this point, any questions? Understood?
Sir,
Yes, sir.
I want to ask, sir.
I cannot quite hear it. It's rather. Yeah.
Itu sir yang untuk kelas 4, yang solution yang adding for 4 itu berlaku jika soalnya itu semisal X minus 5, berarti nanti di bawahnya itu ditambah 5 juga ya, sir?
Yeah, that's correct. What we want here, since we want to find the solution, so we need to find a rule such that X stands alone. So here, X still stands with minus 4, so X minus 4. So we want to try to move the minus 4 somewhere else, or we want to eliminate this minus 4 in this case. Then we have to add plus 4 to all sides. Because if we add plus 4, then the one in the middle, we will have only X. What happens if this X minus 5? Then we simply need to add plus 5 to all sides. That's correct.
Okay, thank you, sir.
Now, we have this inequality. How to solve it? Absolute value of 3x minus 5 is greater than or equal to 1. Now we check this rule again. We have the right-hand side as positive, which is represented by 1. I think 1 is positive, and whatever is inside the absolute value here, now we have this rule. So in this case, we have two cases. Whatever inside the absolute value is less than or equal to minus 1, or whatever inside the absolute value is greater than or equal to 1. That's why here we have 3x minus 5 less than or equal to 1 minus 1, or 3x minus 5 greater or equal to 1. And after that, we just need to solve both sides, both inequalities separately, and we have the solution that is x is less than or equal to 4 over 3, or x is greater than minus 2. If you don't believe me, you can simply put a value, for example, 4 over 3. 3 times 4 over 3 is 4, minus 5 is minus 1. We take the absolute value, it's 1. We have 1 equal to 1. Or we have we take some values that is less than or equal, that is less than 4 over 3. Let's say x is equal to 0. We put 3 times 0, 0, minus 5, minus 5. We take the absolute value, 5. 5 is greater than 1. That's why that x less than or equal to 4 over 3 satisfy this inequality. What about the other side? If we take 2, 3 times 2, 6 minus 5, 1. Then in that case, we have 1 equal to 1. We take some value that is greater than 2, for example, 3. 3 times 3 is 9. 9 minus 5 is 4. Absolute value of 4 is 4. 4 is greater than 1. That's why this part also satisfy this inequality. So in this case, you have to write both solution with or. Still quite easy, right? Any question? No. Then now we want to solve this inequality. We have absolute values on the left side and absolute values on the right side. And both sides of the inequality are positive. So in this case, we cannot really use this rule, because if we use this rule, then we will get something quite messy. And since we know that both sides are positive, we know that absolute value always maps something to a positive value. So both sides of the inequality are positive. In this case, squaring both sides. So if we have a positive value and we square it, the value remains positive, right? So in this case, if we square the left side and the right side of the inequality, the direction of the sign does not change. It will remain like this. As long as the value is greater than 1, actually. Oh, no. Well, if both are positive, yeah. If both are positive, any value, then the direction of the sign remains the same. That's why for this case, we square both sides. We square the left side and the right side, meaning that we have 3x plus 1 squared less than 2 squared times x minus 6 squared. And in this case, we have this inequality after we square them. And then we move everything to the left-hand side of the inequality so that the right-hand side is equal to 0. In this case, we have this quadratic form, 5x squared plus 54x minus 143 is less than 0. After this, the step is the same as what we studied previously. So we factorize this quadratic polynomial into this factor, which is x plus 13 times 5x minus 11. And then after that, we draw the solution line and test the value, and we get that the solution is x is in between minus 13 and 11/5. For this example, any question? Any question?
Nothing, sir.
So
I'm sorry, sir.
yeah,
Maybe I want ask the first step. Yeah.
Yeah.
Kenapa dipangkat 2 itu, sir? Ya, itu aja.
Y square. Okay. Because if we square both sides, then we have of course we will have positive value. So anything that is squared is always positive. I mean, anything that is squared results in a value that is positive, right?
Yes.
And then we know that the left-hand side and the right-hand side of the inequality both are positive. That's why we can square them. So basically, if we have a less greater than or equal to 0 and b greater than or equal to 0, and we have some kind of relation a, let's say a less than b or less than or equal to b, then in this case, a squared is also less than or equal to b squared. As long as the left side is positive, the right side is also positive. So this is greater or equal to 0. B is also greater or equal to 0. That's why we can use the square. Let's check if we don't square the first step. What if we don't square the first step? What do we have there? 3x plus 1 absolute value less than 2 times x minus 6. Okay, in this case, from the rules of absolute values, inequalities involving absolute values, we will have that 3x plus 1, sorry, better than minus 2 absolute value x minus 6, and here like this, 2 x minus 6. We can use this because both, I mean, this part is positive, right? 2 times absolute value of x minus 6. And in this case, since we have absolute values on the left side and the right side, we need to split them into 2 different problems. First, we have this minus 2 x minus 6 less than 3x plus 1, and 3x plus 1 less than 2x minus 6. So in this case, we will have something like this. X minus 6 absolute value is greater than minus 3 over 2 x minus half, and 3 over 2 x plus half less than absolute value of x minus 6. And then after that, we need to split them again into different problems, like since they are greater than, here we have x minus 6 less than minus of this. So we need to check the rules again. So less than minus of that value. Less than 3 over 2 x plus half, or x minus 6 greater than minus 3 over 2 x minus half, and x minus 6 less than minus 3 over 2 x minus plus half, or x minus 6 greater than 3 over 2 x plus half. But also there is an extra rules that says that in here minus 3 over 2 x minus half must be non-negative, greater or equal to 0. And in this case also 3 over 2 x plus half greater or equal to 0. And then you can continue to solve it and until you get the solution, but it takes a long time. You can try to solve it that way, but I'm quite sure that if you get the solution correctly, then the solution must look like what we already discussed by squaring both sides.
Okay, thank you, sir.
Yeah. So we have about 7 minutes left. We have, now try to solve this inequality. Let's try to solve this inequality. X minus 2 is greater or equal to 5. In this case, we have x minus 2 less than or equal to minus 5, or x minus 2 greater than or equal to 5. Here we have x less than or equal to minus 3, or x greater than or equal to 7. This exercise is still easy. Okay, any questions up to this point? No? starting to get confused or what?
A little bit, sir.
A little bit. Okay. But for this problem, is it clear?
Clear, sir.
Yes, sir, but that's clear.
Now we have 5 minutes left, and we have like 8 class home take home challenge that you can do at home. You can try. First is easy. The second challenge is easy. The third one is a little bit harder than the previous one, but still easy. The fourth one is similar to challenge 3. Challenge 5 is like this. Challenge 6 is a little bit harder, but it is not that hard. 7 and 8 might be quite confusing for you. So we still have 5 minutes. Do you want me to try some of this challenge? Please let me know.
Yes,
Yes.
sir.
Which
Yes.
one?
The number 7.
The hard
7?
one.
Which
Yes.
one? Just one. Which one?
7 maybe or 8.
Which one? A, B, or C?
8.
C.
C.
Okay.
C, sir.
C is actually quite easy. Proof, show that a absolute value of A plus B plus C is less than or equal to A plus B plus C. Okay. What do we have? Anyone know what can we use to show that this inequality, absolute value of A times plus absolute value of B plus absolute value of C? What do we have that can help us to show that this is true? Remember the property of absolute value. Triangle inequality. We have absolute value of x plus y is always less than or equal to absolute value of x plus absolute value of y. So, proof. Absolute value of A plus B plus C. Now we just like this. So in this case, we have less than or equal to absolute value of A plus B plus absolute value of C. From here, from the left side to the right side, understood?
I think yes, sir.
Yeah. So we can consider this A plus B as X and C as Y. So we have absolute value of X plus absolute value of Y, right? Here is the triangle. Okay. And then after that, we simply need to split the absolute value of A plus B. Now we consider A as X and B as Y. So we have this is less than or equal to absolute value of A plus absolute value of B. And then we still have plus absolute value of C. the proof is completed. So we have this or QE. So easy, right? So from this, can you try to prove A and B? Okay, try it at home because the time is up. Before I end this session, anyone want to ask questions? Anybody? You can ask me anything. If not, then see you later this afternoon at 2. Let me end this session. Good morning and Assalamualaikum warahmatullahi wabarakatuh. See you later this afternoon.
See you,
Alright.
sir.
Okay, see you, sir.
See you.
Thank you.